Hello, welcome to Data Engineering for AI series. When organizations, business, and users they are start to build AI initiatives, they usually look at the chatbots, agents, models, or platforms. One of the key concepts that they are rarely look at is the data and basically data engineering. In this presentation, I'm going to cover some of the concepts in data engineering foundations that can help us to determine if AI system is reliable and can be trusted or not. So basically, the message for this presentation is simple. Successful AI is not going to start with the prompt which is entered. It is going to start with the reliable, governed, and contextual data. So be with me to see what kind of the concepts we need to look at and we need to consider when we are building the AI-based systems. AI conversations often begin with model selection, RAG, agents, or fine-tuning. Those are valid questions, but they can be premature. A more fundamental question is whether the organization has reliable, governed, current, contextual, and authorized data. If that foundation is weak, a more capable model may simply express unreliable information more fluently. From the outside, AI can look like a user asking a question and a model producing an answer. In production, the model is one stage in a broader architecture. Information must be collected, transformed, validated, enriched, governed, retrieved, and monitored. Most of the reliability work happens before the model receives context. This is why data engineering is part of the AI system, not merely a supporting activity. A sophisticated model cannot fully compensate for outdated, duplicated, incomplete, incorrectly linked, or context-poor data. An answer may be linguistically polished while still being operationally wrong. For example, a system can accurately quote an absolute policy or retrieve a historical diagnosis without recognizing that it is no longer current. Reliability, therefore, depends on data quality, currency, linkage, context, and interpretations, not only model accuracy. Data quality is often treated as a project state cleanup exercise. In production, it is continuous because source systems evolve, schemas change, new records arrive, definitions shift, and permissions are updated. Useful controls include completeness, validity, duplicate, timeliness, referential integrity, business rules, schema drift, and anomaly checks. The aim is to detect deteriorations before unreliable information reaches users or AI systems. Data without context is easy to misunderstand. A field name status or a date can carry different meaning across systems. In clinical text, a condition may be current, historical, suspected, or explicitly ruled out. Metadata explains meaning, provenance, ownership, effective time, usage restrictions, and transformation history. This context is essential because AI can produce convincing response even when the key meaning is missing. Governance and security are not finishing tasks. An AI system should retrieve only information the user is authorized to access. That requires role-based access, classification, privacy protections, content management, retention rules, masking, secure retrieval, audit logging, and policy enforcement. These controls should be designed into ingestions and retrieval rather than added after launch. Retrieval augmented generation or RAG is much more than placing embeddings in a vector database. A robust pipeline prepares documents, chooses chunking strategies, enriches metadata, creates embeddings, manages versions, filters by permissions, ranks relevance, assembles context, and evaluates retrieval. If the retrieval layer selects irrelevant, outdated, duplicated, or unauthorized content, the generated answer will be unreliable. In many systems, retrieval improvements create more value than changing the language model. Healthcare demonstrates the importance of data engineering because errors can affect safety, privacy, and trust. Before an assistant summarizes clinical notes, results, medications, diagnosis, or discharge documents, the system must establish correct patient linkage, currency, duplicate handling, terminology, negation, temporal context, privacy, permission, and traceable evidence. These are data engineering, terminology, governance, retrieval, and system design concerns, not model question alone. At Info2K, a core principle is that AI should assist people rather than blindly replace them. AI can find information, summarize content, classify documents, detect patterns, and reduce repetitive work. People remain essential for context, judgment, validation, ethics, care, responsibility, and accountability. Reliable data engineering creates safer conditions for this relationship and partnership by improving the information AI uses and making governance and evidence visible. This presentation opens a 9-part Info2K learning series. Part 2 defines AI-ready data. Part 3 compares ETL and ELT. Part 4 explains reliable RAG pipelines. Part 5 focuses on data quality for AI. Part 6 explores why clinical language needs specialist handling. Part 7 connects responsible AI with responsible data. Part 8 looks at cloud data platforms for AI. Part 9 brings the theme together as modern data engineering for enterprise AI. Each part builds on the same idea. Information becomes useful knowledge through engineering, context, and governance. To wrap up, just keep in mind, successful AI does not begin with the model, it begins with the data. If you found this useful, please subscribe to the Info2K YouTube channel. We'll continue this learning series with more practical videos and explanations. Additionally, please follow the Info2K LinkedIn page. We will share the next articles and videos in the Data Engineering for AI series, practical technical insights and updates about the application and solutions we are building for the future. Thank you for joining us on the journey from information to knowledge.